Okay, last thing. What's sine and cosine? What? No, actually, it doesn't. It has to do with x and y coordinates. So I'll try to explain it. The cosine of an angle is the x value of the point on the unit circle. So it's of an angle. So the first thing, not just, it makes me crazy to see it, but if you type cosine and hit enter without putting anything in it in your calculator, just try it. Your calculator will say error. So you should have something that you're just going to stick in the cosine, because the input of a cosine is an angle. And in your WebAssign and anywhere you see in your other classes, they'll have cosine of theta or cosine of t, meaning that you're supposed to plug in an angle inside the cosine. And its definition is it's the x coordinate. So for example, cosine of pi over 3 is the x value of the point. So if I go to, I think I meant pi over 6, but if I go to pi over 6, and I look at this dot over here, there's a distance to go across to get to that point. That's the x coordinate. The definition of that x coordinate is the cosine of that angle. So cosine of pi over 6, it turns out is about 0.86. So if you actually measure it with a ruler and you're a good measurer, I mean, you're going to find in your lab classes who works well with measuring things right and works well, doesn't as well. But if you go to pi over 6 and you actually look at the measurement up here, it's around 0.866. The exact answer is square root of 3 over 2. So these experiments I don't want to run in class today, but they're really fascinating. The ancient Greeks, they had run these same experiments you did in class today. And they found it very weird that all the way across and all the way around turned out to be a ratio of around the same thing. And what that number would be. Square root of 3 over 2 was another mystery to them.
So basically, for the sine, it's an ordered pair, but you took
the sine is the y coordinate.
You took the y coordinate and you converted it from a radian to a degree?
No, it's all radians.
Oh.
Yeah. In math class, we use radians. So what is the of cosine at, it should be pi over 6. I'll change that on the notes that go up. But cosine of pi over 6 is 0.866. What's the sine of pi over 6, not pi over 3? Sine of pi over 6 is the y value at that point. So if you go back to the unit circle, to that black dot I made up there, the y value, see, I went across farther than I went up, right? The elevator went up about 0.5 in height. It went across about 0.5. So the y value up here is 0.5. And it turns out that the y value of pi over 6 is 0.5. I'll change these to pi over 6 in the video so you can see it. So what's the x value here? Like if I go here, how far did I have to go across to get to this zero angle on that unit? So how did I have to walk? So I had to go from the center and walk 0.8 to get to this point. This 0.8 was here. What's this called? What's all the way across called? What's halfway across? Radius. Radius. What is this? A radius of this circle? 1, because it's a unit circle. So the x coordinate would be 1. How much did the elevator have to go up or down to reach this point? 0. So the y coordinate is 0. The elevator going up and down is your y. How much you had to walk across was the x. So I had to walk across a distance of 1, and the elevator didn't move up or down. So the y value is 0, and the x value is 1. So the cosine of 0 is 1, and the sine of 0 is 0. Cosine is the x, sine is the y. So x is 1.
Your y is still 1 even though you only went over half?
I didn't, I went over 1. The unit circle means halfway across. Radius is halfway across. Your unit circle means halfway across is 1. All the way across is 2.
Okay.
Right? Halfway across is 1.
Okay.
y value is 0. So get that. So cosine at 0 is 1, sine at 0 is 0. So I can start filling in all the pieces. It turns out right here, you probably did some work in class in high school where they talked about square root of 2 over 2 and right triangles. It turns out that the x and y, this is the 45-degree line. That's where x and y are both equal. Square root of 2 over 2, square root of 2 over 2. The x and y values are the same. Right here at the very top, it's reversed. A half is the x value, square root of 3 over 2 is the y value. What about pi over 2? Again, that one's one you can figure out. So right here, I want to go up to the top edge at pi over 2. So let me put my mouse up there. What is the x? How much did the x have to, how much did you have to walk? Here, let me get my mouse. 0, right? I didn't have to walk anywhere, right? No walking right or left. I stood still. And I punched the elevator button. How high did the elevator have to go to hit the top of the 1? So the y value here is 1, the x value here is 0. So cosine at pi over 2 is 0, sine of pi over 2 is 1. So it should make sense. So when someone's in calculus 3 and we have cosine at pi over 2 and they don't know the answer to that, what do you say to that? What do you like to say to them? You didn't have Dr. T for pre-calculus. That's what you say. Okay? It should make sense. And pi over 2, 0, pi, and 3 pi over 2 should be the easiest ones. You should know what the cosines and sines are of there at those points. How do I get the rest of the circle? Well, the rest of the circle is pretty easy. You don't have to do any analysis. In this circle, so when I walk this way, x's are positive. When I walk this way, x's are negative, right? So I'm in the center, I'm walking that way now. So the x's are negative. So all the x values are negative. The elevator always goes up in this region. So the y values are positive. And now I can fill in all the rest. I did it all at once. How do I get, well, I had a walking distance of -1. That one's easy. How about this one? Well, the elevator went up the same amount here as it did here. So the elevator went up a half. So I just look over and say, okay, this one went up a half, so this one has to go up a half. And this one, well, that's just the reverse of that one. But that one I walked a distance of positive square root of 3 over 2. So this one I have to walk a distance of negative square root of 3 over 2. That's how I get all the rest of them. And in fact, the third quadrant, the x's are negative in the third quadrant because I have to walk that way. And the elevator goes up or down? Down. So the elevator goes down in this region. So I can fill all those in with the same logic I just used. And the last one's easy too. So the rest of it's pretty easy. And that's how you fill in the entire thing. So over here, for example, this point right here. Well, I walked over the same amount here as I did here, right? That's the same distance I walked over to the right. Over here to the right, I had to walk over square root of 3 over 2. So over here, I had to also walk square root of 3 over 2. The same distance on the x-axis. But the y-axis, instead of going up, I had to go down. So I just take that point and I go an equal amount down, -1/2. So what do you need to know for Monday's quiz? You have to know the circle. You have to recreate the circle. I gave you the logic behind it, so you shouldn't memorize it. There was one student last semester that tried to memorize it, and she kept getting a few points here and there wrong. And I told her, why don't you go back and watch the video and see how to create it? Because 5 years from now, you might not remember me. But I hope you remember how to create this circle. In fact, I suggested to them that they might get a tattoo. It'd be a great dinner table conversation, wouldn't it? Wait till you see my tattoo. Wait till you see my tattoo. So you have to know that you have to be able to recreate the unit circle with angles and x, y values. And the rubric for this unit circle was the very first module that I showed you. That rubric goes with this circle. So I don't want to see it in degrees. You can put the degrees there if you want to, in addition to putting the radians, because the radians should make sense of where it's all coming from. So this is what I want for number 1. Fill this whole thing out. Second thing, you have to be able to, once you create the whole circle, if I give you an angle, you should be able to give me the sine and the cosine of those angles from the circle. So that's how the question's asked. What is the sine and the cosine? So I ask, find the angle where the sine and the cosine turn out to be minus square root of 2 over 2. And so to see them on the top, the question being asked. So you have to go just look off your diagram and find it. So you just go back to the diagram and say, where is the x coordinate negative square root of 2 over 2? Right up there, I see it, negative square root of 2 over 2. And I also see it down here. So there's 2 answers. So once you have the circle in place, you can answer any questions that anybody wants you to answer them. And 2 through 5 in WebAssign, which is the conversion to degrees to radians. I think number 1 and 2 are just unit circle again. It's the same thing that I just asked you to do. And I will have one why pi question. Why do we use pi in math classes, and why do they use degrees in physics classes? So it's your in-class assignment. So I think everybody understood why we do that. Yes?
Can you explain that?
I don't have to, it's on the video. I think when people are sitting in, what are we, 1 and 2 hour and 42 hour, almost 2 hours we're sitting here. I don't expect you to be sitting there in rapt attention. I would be honored if you did. But I've been told also that my lectures are really, people are engaged, but then they forget what I just said. So that's why the videos are really helpful.